Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So today, eventually, we're going to take a look at section 14.1. But first of all, we have some questions from 4.5 from yesterday. And so I want to take a look at those. And let's see here. So you should be able to see a WebAssign problem on your screen. Is that true, everybody? Did I click the right buttons? Just somebody tell me yes.
Yes.
Thank you. Because sometimes I forget to push the right buttons. Okay. And some of you feel like I push all of your buttons, but that's another story. All right. So a student had some questions from the WebAssign assignment. And first of all, I want to look at their answers. And of course, you don't know who this is, which is the way it's supposed to be. But I want to talk about what they did that I think is why it's wrong. Okay, so problem number 5, graph the solution of the system. I'm looking at it and looking at this line right here, there's just a ton of points there and a ton of points here. And this line is supposed to be dashed. And when you put a bunch of dots on the line using the wrong button, it tends to reject things. And so even though you as a student may be doing the problem correctly, WebAssign is very picky on what it will accept. And so what I want to do now is I want to look at how we would go through and do several problems the way that's necessary to do it in WebAssign. Okay, so let's see here. What I want to do now is open that up. You know what? I can't. Well, yes, there we go. Okay. Hang on. I pushed the wrong things first. Let's see. We need to close that. And I need to close that. I'll get this right yet. You'll see. Okay. So I want to share that screen, but I want to have the graph up. Okay. Can everybody see the graph now?
Yes.
Thank you. I know it's a pain to have to keep answering me, but like I said, I've had it happen on occasions where I'm working away on a problem and like 3 minutes into the problem, somebody will say, "Oh, Mr. Mayo, we can't see what you're writing on the screen." And I'm like, why didn't you tell me? Okay. So that's why I'm always checking on that. All right. So the first problem that we're going to look at, this was number 5 in the assignment 4.5. Your particular problem may not be this exact one, but it would certainly be very similar. Okay. And it says y is greater than 2x minus 8. And our second equation, or inequality, excuse me, is y is greater than or equal to negative x minus 2. Now, this particular problem, both of the inequalities are already in slope-intercept form. So I'm going to go ahead and do them that way. I don't know if the student did it that way, but the next problem I'll do a different way. But so taking a look at the black inequality, it's already in the form of y equals mx plus b. So the slope is 2 and the y-intercept is negative 8. So graphically, we would have a point here at negative 8. And then using the slope, we'd go up 2 and over 1, up 2 and over 1, up 2 and over 1, etc. Because it does not include the equal sign, our line that we're going to graph, in fact, is going to be a dotted line. Okay. Then it says y is greater than, so we would be shading above that line. So that would be the part that's in black. Now let's take a look at the part that's in red. So using the form y equals mx plus b, here the slope would be this implied -1 coefficient, and the y-intercept would be -2. So -2, down 1 over 1, down 1 over 1, down 1 over 1. Here we have the equal sign included, so we're going to have, let's see here, I'm going to put my glasses on so I can see better. Okay, we're going to have a solid line. And that's going to look like that. Y is greater than or equal to, so we're looking at that piece right there. Now, the solution I'm going to do in green, and that would be this piece. Okay. Any questions about that problem at the moment?
So quick, just kind of a refresher, when you use the y-intercept form, you don't have to test your points as you would if you just pick two random numbers, right?
Exactly, because when you put it in that form, if y is greater, it's above. If y is less than, it's below. This method is way quicker usually. Now, when your y-intercept is a nasty number, like a fraction, then things get a little trickier and you have to do some addition and things to get things to go. But in general, this way tends to be quicker. I will do the next problem the other method though. Okay, now, so what we've got there, let's see here, I want to write some things down to save. The first one had a slope of 2 and a y-intercept of -8. And it was above the line. The second one had a slope of -1 and a y-intercept of -2, and it was also above the line. Okay, so now I'm going to close this up, and we're going to go back to this. Okay, let's see. That first line is this one, and there's a y-intercept of -8 and a slope of up 2 over 1. And let's see, it's supposed to be dotted, so it looks good. The second line has a y-intercept of -2 and a slope of -1, and it's solid, so it looks good. So everything looks good on this graph. Why is it wrong? Well, as far as I can tell, the problem with WebAssign is this particular graph where this line that's supposed to be dashed. When you plot points on there, more than 2 points, and not using the button that's over here, and we'll look at that in a minute, and then it's supposed to be a dashed line, WebAssign says, well, wait a minute. If it's got all these points on it, then it's not dashed, because dashed, really, there's no points there. It's just establishing the boundary. So you've really got to use the method that I'm telling you. And I've had people say that the WebAssign videos don't do it this way. So in my egotistical way, I'm going to say, do it the way I'm showing you. Okay. Now, having said all of that, I'm going to go back and graph it in WebAssign. I'm not going to use this graph because I can't manipulate that one, okay, because that's students. So what I need to do now is, let's see here, I'm going to go back to home. Give me just a minute here. Student view, we'll take that. Okay, come on. And 4.5. Okay. Now, let's see here. I'm going to go share screen. So now, again, can you see a WebAssign screen?
Yes.
Okay, now, this problem up here is not the one I'm going to work. I'm going to work the problem that I just did in the other screen, okay? But here is what I know. I know that the first line had a slope of 2 and a y-intercept of -8. So I'm not going to click on this thing. I'm not plotting points. I'm establishing a line, okay? So I've got to use this right there when it turns blue, okay? So the y-intercept is -8. The slope goes up 2 and over 1, okay?
How come
Now,
it goes over 1 though? That's where I get like stuck, because I usually kind of think that it'll be the oh wait, I don't know.
tell you what, when we're done with this problem, remind me, and I'm going to look at how a slope works if we need to review that concept, and that's fine. It sounds like we need to. Okay, this one was just greater than, so I need to make it dashed. Okay. Now, also, it's above because it was greater. And again, these are not the correct numbers over here, so don't be using that. So I'd go fill, and it would fill over there. So that's what the first part of the graph would look like. Okay. Now again, I established that line not using the dot, but using this button. And notice there's only 2 points on there, but when you do it this way, the WebAssign says, oh, it's okay. Okay, this establishes the line, but those points aren't really there again. Okay, now the second line that was the y is greater than or equal to -x minus 2. Again, it's different from this. Let's see, we had a y-intercept at -2 and a slope of -1. So that point right there, okay? This one was greater than or equal to, so it's a solid line, okay? And to shade it, it's going to be filled on that side. Okay, now, actually, let's see here. So let's see what I want to do now. I want to go back. Let's see, there we go. Okay, this dashed line, it was supposed to be over here and over here, okay? The solid line, it was supposed to be over here and over here. So where do they intersect? Well, this and this intersect there. So there is the correct solution. Now, if I click submit answer, it's not going to be correct because this problem is, again, different from the one I'm working. But look at what I've done there, okay? This is the process, and I get a lot of questions from students, and I really think you need to watch the videos I'm making or be here at the Zoom session, okay? Because it's not very intuitive. It took me a long time to figure out how to do it on WebAssign. All right? Any questions about this particular problem? Okay, I'm going to do one more, and I'm going to do that one using the point method. Okay, and then if the student who had all these questions is still having questions, email me and I'll get in touch with you. I tried earlier today, but you didn't answer your phone, doggone it. All right, that's fine. Okay, so now, let's see here. Can you see my graphing grid?
Yes.
Thank you very much.
Yeah.
Thank you. Okay. And let's see. Okay. And here, and here, and here. Okay, so this set of inequalities, this is number 9. It says 2x minus 3y less than 0. And 2x plus 3y greater than or equal to 17. And again, the particular problem that you did may have different numbers as part of it. Okay. So let's look at the black inequality. 2x minus 3y is less than 0. So we're going to consider the equation 2x minus 3y equals 0. And we're going to make a table and find two ordered pairs. Now, in theory, we can pick any number we want for x or any number we want for y, but you have to live with the consequences. So you want to pick something nice, something small, something simple. So let's see. Tell you what, let's do this. Let's let x equal 0 and find y. So using this equation, 2 times 0 minus 3 times y equals 0. Negative 3y equals 0. Divide both sides by negative 3, y equals 0. Oh, this thing goes through the origin, 0, 0. Well, I was going to pick y equals 0 for the next point, but that's just going to give me the same point, the origin. So how about if we pick, oh, let's see. Well, let's just pick 1, okay? So if x is 1, 2 times 1 minus 3y equals 0. 2 minus 3y equals 0. I'll subtract 2 from both sides. Negative 3y equals negative 2. Divide both sides by negative 3, and y equals 2/3. Okay. So plotting those 2 points, we've got 0, 0, and 1, 2/3, which is right about there. Okay. Now, let's see, I need to draw a line. Oh, but in my original, it did not include equals, so I need to draw a dotted line. Okay. And let's see here. I'm not going to make this super accurate because my points, you know, to make a more accurate graph. Now in WebAssign, you can adjust things, but on my graph here, I might pick some larger number so that I get a point, you know, further out here kind of thing to graph. But we'll go with this for right now. So let's see here.
Could you show us in the slope intercept method as well with the problem?
Yeah, we'll see how time permits. I'll try to, but yeah.
Okay.
And again, and I'm not wanting to discourage any of you at all, but if you do have a lot of questions, you really should come to my office hour. And if you can't do that, contact me and I'll get in touch with you. But again, I've been having a hard time tracking students down, but we'll keep at it here. Okay, and then let's see. So we need to pick, oh, we can't use 0, 0 as a test point because it goes through 0, 0. So how about if we pick, let's see, let's pick this point right there, 2, 0. Okay, now I'm going to plug it back into my original inequality. So if x is 2 and y is 0, I get 4 less than 0. 4 is not less than 0, so this is not correct. So the graph would be up there. Okay. Any questions about that? All right, let's take a look at the red inequality. And let's see here. Tell you what, let's use x as 0 again. And so we'd have 2 times 0 plus 3y equals 17. 0 plus 3y equals 17. 3y equals 17. Y equals 17/3. Oh, that's lovely, isn't it? 17/3. Okay, so let's see. X is 0. Y is 17/3. 17/3 as a mixed number would be what, 5 2/3? So we're right up there. Okay. Let's see. How about we use let's make y 0 and see what happens there. Okay, so then we get 2x plus 3 times 0 equals 17. 2x equals 17. X equals 17 halves. Wow, not nice at all, is it? Okay, so when x is 17 halves, which would be what? 8.5. So hang on here. I'm going to move this out of the way there. And let's see. 8.5 would be right about there. Now, that line is going to be solid, okay, because it includes equals. I should have made this into a line as well. We can use 0, 0 as a test point, so let's plug 0, 0 into that. Oh, greater than or equal to. So we get 0 greater than or equal to 17. That's not true, so it goes this way. So our solution is up there. Okay, now I'm going to write down some information there. The first one, the 2x minus 3y less than 0, included the points 0, 0, and 1, 2/3, and it was above. The second one, 2x plus 3y greater than or equal to 17, we had 0, 17/3, and 17 halves, comma 0, and that one was also above. Okay, why am I writing all that down? Because now I'm going to go away from that. And let's see here. I'm going to stop sharing for a moment. And let's see. I forget if I've gotten rid of, good. WebAssign is still open. Now, again, I'm not going to do this one. I'm just going to use the grid to graph the one I just did so that you see the steps. Okay. And hopefully at this point, if somebody says, oh, you made a mistake, I'll strangle myself. So don't do that. Okay. Now, the first one, which was 2x minus 3y less than 0, we established the point 0, 0 and 1, 2/3. Okay, and that was a dotted line or dashed. Now, I'm not convinced that that point got put at 2/3, at 1, 2/3. So I'm going to click on the line. Oh, it didn't. Let's see. I had 0, 0, and then, oh, part of my mistake was the scale. Look at that. The scale was 2s instead of 1s. So this is way off, but that's okay. I can fix it. I'm going to put in a 1 for x and a 2/3 for y. Okay. So there's my first, that's that dotted line. Okay. And let's see, it was above the line. So if we're going to fill it, it would look like that. Okay. So that's the 2x minus 3y less than 0. Now, let's see. Let's take a look at the second one. So again, we're going to get the solid line there. X was 0, y was 17/3. 17/3 is what, 5 2/3, which is about there. Okay, so 0, 17/3. And then the other one was 17/12, comma 0. 17, excuse me, 17 halves. That's about 8, 8.5, 0. Okay, now that line's solid, but again, my points may not be where I wanted them. So I'm going to go here. This was supposed to be 0, 17/3. Okay. And then this was supposed to be 17 halves, 0. Okay. So now my graph should be accurate. Both of them were above the line. Well, if we go above the dashed line and above the solid line, that's going to be our solution. Okay. So again, that is how you need to do these kinds of problems in WebAssign. You don't want to plot a whole bunch of points and then it ends up being a dashed line and then WebAssign says it's wrong and you're frustrated. Do it this way and it will work. Okay. All right. We're going to go back and do that same problem that we did a minute ago. And somebody asked to see it using, let's see here, using slope-intercept form. So now you should be able to see, I didn't want to do that. I moved this whole thing over. There we go. Well, doesn't matter. Okay. All right. And let's see, it was 2x minus 3y less than 0 and 2x plus 3y greater than or equal to 17. Okay, now this is using the slope-intercept form method. So the first thing we're going to do, we're going to go back to the black inequality and we're going to solve it for y. So I'm going to subtract 2x. So I get negative 3y less than negative 2x. I'm going to divide both sides by negative 3. So I change the direction of the inequality symbol because I divided both sides by a negative. So I get y is greater than 2/3 x. So the slope is 2/3 and the y-intercept is 0. So over here, it's going to go through 0. My slope is up 2/3. Somebody was concerned about the slope. So let's talk about the idea of the slope. Okay, let's just look at that. Here, we'll put it over here and then we'll erase it here. If I have 2/3, the numerator of that fraction is the up or the down. That's the y value. The denominator is the x value. Okay, you're always going to want to do a slope from left to right. And if there's a negative sign somewhere in that fraction, you want to assign it to the numerator. So you're always, if it's positive, you're going to go up. If it's negative, you're going to go down. And then you're always going to go to the right. So what that means is, let's see here, get rid of all that stuff there. 2/3, we're going to go up 2 and over 3. Okay. And I could do that a couple times, up 2 and over 3, up 2 and over 3 if I wanted to. Now, this is going to be a dotted line or dashed line because there's no equals involved. And it says y is greater than, so we're talking above. If y was less than, it would be below. Okay, so there's doing the black inequality. Now let's take a look at the red inequality. Before we do that, any questions? Okay, so now I'm going to take the red inequality and solve it for y. So I'm going to subtract 2x from both sides. So 3y greater than or equal to negative 2x plus 17. Divide everybody by 3. Y is greater than or equal to negative 2/3 x plus 17/3. So the slope is negative 2/3 and the y-intercept is 17/3. Is that right? Okay. So 17/3 would be what, 5 2/3? So 1, 2, 3, 4, 5 2/3. Now, this is going to be a little tricky. I'm going to go down 2 and over 1. So I'm going to go down 2. So that's 1, 2, or down 2 and over 3, excuse me. 1, 2 and over 3. 1, 2 and over 3. That's going to be a solid line. And my graphing, unfortunately, with the ruler I'm using everything here, is not super accurate. You can see how my line isn't quite on those dots because trying to line it up with a ruler. And then y is greater than or equal to. So our solution would be up there. All right. So that's how you would do this using slope intercept form. I'll give you a minute here to finish writing some things down. I can see people frantically writing stuff. And again, keep in mind, this will be on YouTube later. So if you miss something, don't get something written down, you can always go back and view it. All right, so I'm going to get rid of that. And see if I can get that over here. There we go. That's where I want it. Okay. All right, now we're going to take a look at the new stuff. So we're going to come back here and so now can you see my whiteboard screen that I'm scribbling on there? I'll take that as a yes. Okay. What we're going to look at today is an operation, if you will, that is called factorials. And the symbol for a factorial is an exclamation mark. Now, if I have 5 factorial, that means I have 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So 5 factorial equals 5 times 4 times 3 times 2 times 1, or 120. Well, let's see. 4 factorial would equal 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. Oh, times 1 is still 24. Okay. 3 factorial is 3 times 2 times 1, which is 6 times 1 is 6. 2 factorial is 2 times 1, which is 2. 1 factorial is just 1. By definition, 0 factorial also equals 1. And we'll deal with that here shortly. Okay. Now, 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. Which I'm not going to multiply that out right now, but you understand how that works. Now, I could also write this as 10 times, well, isn't all of that equal to 9 factorial? Because 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4, etc. Okay. I could also write it as 10 times 9 times 8 factorial, because here, now let's see, let's change colors. That would be 8 factorial. Okay. This could be written as 10 times 9 times 8 times 7 factorial. Let's see, let's get a different color there. How about purple? That would be 9 times 8, or 10 times 9 times 8 times that. Okay. All right, let's see if we're understanding what I'm trying to get you to see there. Okay. Now, let's take a look at some problems. Let's say we have this 9 factorial divided by 11 factorial. Now, the long way of doing this would be to say, oh, that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, that's the long way. Let's see. Oh, the 9s would reduce, the 8s would reduce, the 7s, the 6s, the 5s, the 4s, the 3s, the 2s, the 1s would reduce to 1 over 1. And so I'm left with 1 over 110. Okay, that's the long way of doing this problem. It's not the wrong way, but it's the long way. Now let's look at the shorter way to do this problem. Well, 11 factorial could be written as 11 times 10 times 9 factorial, right? Those reduce down to 1, and I'm done. Okay, so what I did was I said, hey, I can take that and break it apart to some stuff, and then that thing, which then reduces 9 factorial over 9 factorial, reduces down to 1. You see what I did there? Any questions on that move? Some of you are probably wondering, when will we ever use this? Well, especially those of you that are going to be going on and taking statistics, this will come up in statistics, and quite a few of you on this pathway are going to be doing that. All right, let's take a look at, let's see, another example. This says 7 factorial over 5 factorial times 0 factorial. Okay, so here's what I'm going to do. 0 factorial, we said by definition was just 1. Okay. 7 factorial could be written as 7 times 6 times 5 factorial. I could now reduce the 5 factorials on the top of the bottom, and I'm left with 7 times 6, which is 42. Any questions on that?
So do we just ignore the 1 then?
Well, what's 1 times 1? And what's 42 over 1? So I'm not ignoring it. I just didn't bother to write the simplifying it because 7 times 6 times 1 is still 42 on top, and 1 times 1 is 1 on the bottom, and 42 over 1 reduces down. I've got too many little scratch marks there. 42 over 1 is 42. You okay with that?
Yeah.
All right. Let's see. Let's say I have this 5 factorial times the quantity 8 minus 5 factorial over 4 factorial times 7 factorial. Okay. Now, in the numerator, order of operations inside the parentheses, 8 minus 5 is 3. So I get 5 factorial times 3 factorial in the numerator. In the denominator, I have 4 factorial times 7 factorial. Any questions how I got there? So what I'm going to do is I'm going to try and chip away at things the way I can reduce things the most. Okay, let's see here. If I take these two right there, okay, I could write the top as 5 factorial and the bottom as 7 times 6 times 5 factorial. Okay. Let's see, let's go green. Let's look at these two. I could write that as 3 factorial over 4 times 3 factorial. What am I doing? The 5 factorial and the 7 factorial. I can take a 5 factorial out of both of them. And I'm left with 7 times 6 on the bottom. These become 1 over 1. The 3 factorial over the 4 factorial. I can take a 3 factorial out of both of them to get 1 over 1. So what have I got now? On top, I've got 1 times 1. On the bottom, I've got 4 times 1 times 7 times 6 times 1. Okay, which is just what? 4 times 7 times 6? Well, let's see. 7 times 6 is 42, times 4 is 8, 168. Now, this is one of those things where I'm going to tell you, some people aren't going to do this and they're going to get it wrong. Most likely, it's going to want a fraction answer. Okay, so here's a common mistake. I'm going to take 1 divided by 168 and I get 0.00595238. Oh, you know, I'll just round it off to something. And they put in a rounded off answer and it's wrong and they don't understand why. Okay, leave it in fraction form, but reduce down as much as possible. All right. Do you have any questions about this problem before we look at another one? Okay, let's look at another one. 6 factorial times 7 factorial over 8 minus 3 factorial times 7 minus 4 factorial. So what I'm going to do now is order of operations. I'm going to do the stuff in parentheses. 8 minus 3 is 5, so this becomes 5 factorial. 7 minus 4 is 3, and then 3 factorial. Okay. I can take the 5 factorial in the denominator out of both the 6 or the 7 factorial, so I'll just do that. And then later I can take the 3 factorial out of the 7 factorial. So here's what I'm going to do, okay? I'm going to take this and write it as 6 times 5 factorial over the 5 factorial in the bottom. So all of this becomes that, okay? Why am I doing that? So that I can cross out or reduce out the 5 factorial on the top and the bottom. And I'll come back and do that here in a minute. Now let's take a look at this. I'm going to write 7 factorial as 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. So all of this becomes all of that. Why am I doing that? So I can reduce out a 3 factorial. So now these reduce down to 1 over 1. These reduce down to 1 over 1. In the numerator, I have 6 times 7 times 6 times 5 times 4. And in the denominator, I have 1 times 1. Now I'm going to go to my calculator because I can't reduce it any further. And I'm going to say, okay, 6 times 7 is 42, times 6 is 252, times 5 is, 1260, times 4 is 5040, and 1 times 1 is 1. So my final answer is 5040. You okay with that? All right. Now, I'm not sure why, but in the past, there's been a calculator. I've gone online and just Googled factorial calculator, and a wonderful calculator came up that I recommended everybody use, blah, blah, blah. I don't know why, but it's gone. I can't find it. I've looked and looked and looked. So what I am going to do, though, is show you how to deal with a problem like this, for instance, 11 factorial. Now, You could sit there on your calculator and go 11 times 10 times 9 times 8 times 7. You don't want to do that, okay? So how can we do this just by using our calculator? Well, first of all, if you have the calculator that was recommended for this class, which is a TI-30X Roman numeral 2, and then either an S for solar or a B for battery. If you have that calculator on the screen, I believe, let's see here, there's a button here that says second, and then here it says something, and here, right there, it's like the second one over and the second one down, it says PRB, probability, okay? And I believe if you push that key, it then gives you some options. And one of those options is an exclamation mark. So basically, let's say you want to do, well, let's take a smaller one. Let's say we're going to do 3 factorial, which would be 3 times 2 times 1 is 6. Okay, so we know the answer is 6. On your calculator with everything cleared, you're going to put in the number 3. Then you're going to push this PRB button, choose the option that's the exclamation mark. So it'll look like that, and then push equals, and it should give you 6. Okay, now that's if you have that calculator with that button on it. Okay, if you have a different calculator, I have no idea what you've got or where that button would be, but let me show you. So now I've told you that during tests, you're not to be looking stuff up on the internet. This is one thing you can do, just if you need this calculator, but only for this. Okay, let's see. I guess I need to share my screen here. So I'm going to type in factorial, whoops, calculator, and it used to be that the first one that would come up was the nice one, and it would be an entire calculator. So all this really does is gives you that ability to do a factorial. So the problem that I asked about was 11 factorial. So if I put 11 in there, so that means I'm finding 11 factorial and calculate it, there it gives me an answer. Okay, now how do you read that answer? Well, all the way down at the bottom is the full answer, 39,916,800. What they've done here is write it in scientific notation. So it's 3.99168, and then this E plus 7 means it's 3.99168 times 10 to the 7th power. So 11 factorial is, I'm going to write this down on my other screen here. Oops. 11 factorial is 39916,800, which is 3.99168 times 10 to the 7th power. Okay, so where did I go again? I typed in factorial calculator. Now let's go back to the other screen. And so 11 factorial is 39,916,800, or in scientific notation, so they're moving the decimal point 1, 2, 3, 4, 5, 6, 7 places, it would be 3.99168 times 10 to the 7th power. Now, WebAssign might say, give the exact answer. It might say, write the answer to 3 decimal places. Okay, read the directions in WebAssign. That's another. So many points were lost last quarter from students that didn't really read the directions in WebAssign. They looked at the problem and said, oh, I know what to do. And then WebAssign asked for some little detail and they didn't read it. And so they missed half the problem. So read what the directions say. Okay, I've nagged you enough for today. So it's time to go. I'm going to stop the recording.